Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Dr. Muhammad Azrin bin Ahmad and I'm from Center for Mathematical Sciences. In this video, I would like to share the results of my paper entitled Pattern of the String of the Nth Order Limit Language for the 3rd International Conference on Applied and Industrial Mathematics and Statistics ICoAIMS 2022. But before that, I will introduce the motivation that drives us to produce the result in this paper. Our research is an interdisciplinary study that relates between formal language theory and informational macromolecules in biology, which we will focus on deoxyribonucleic acid or DNA. DNA is made up of 3 essential parts such as a phosphate group, a sugar group, and nitrogenous bases. The nitrogenous bases such as adenine, cytosine, guanine, and thymine can later be abbreviated to ACGT is the focus of this research. By Watson-Crick complementarity, the only possible pairings between the bases are A with T, C with G, and vice versa. After the cutting and pasting occurs on the DNA, it will produce set of strings which later can be grouped as a language. Previously, the nth order limit language has been revised and reintroduced based on the extension of limit language. Based on this new revision, we define the nth order limit language by the number of rules that act on each crossing site, where the rules are different from each other. The set of rules must have the same length of the crossing site. Our research is aimed to study the relation between M initial strings and R rules that form nth order limit language in the head splicing system. Previously, research that investigate how our rules affect the emergence of nth order limit language was conducted. This time around, we would like to present the results on how M initial string affect the outcome of the nth order limit language. Then, by using the findings from both research, we will provide their relation to the formation of the nth order limit language in the splicing system. Here are the preliminaries of the research. The basic concept will be used throughout this research. On to the main results of this research. We have a lemma and a theorem. As mentioned earlier, the research focuses on the role of M initial string that affect the formation of nth order limit language. Here is the lemma. If M initial strings are considered in the splicing system, then 2M squared plus M strings of the language is observed. My explanation to the lemma is as follows. Based on the findings in it, no matter how many R rules involved in the splicing system, the following number of strings in the language are produced, which can be generalized into 2M squared plus M. The next table is useful when we want to prove the lemma by using double induction method. Here, we introduce GMR as a function that presents the pattern of the strings with M initial strings and R rules. Double induction proving method is applied since there are 2 variables in the function. By using the results in paper and introduction to nth order limit language and lemma 1 in this paper, the following theorem is presented. In this theorem, when head splicing system contains M initial strings and R rules, then the nth order limit language produce 2M squared plus M strings and 2R minus 2 combination of strings. The nth order limit language is given as follows. To conclude the findings of our research, basically with M initial string and R rules, 2M squared plus M strings are produced. Through the theorem, it is evident that both string and rule are independent to each other, such as R rules produce 2R minus 2 combination of string and M initial string affect the pattern of the string of the language. With that, I thank you for watching the video of my presentation. I hope to see you around, and till then, bye!